Hi, my name is Carla Fernández González, and my partner Teresa and I are going to tell you about the Winograd Schema challenge. This is a brief introduction of the topics that we'll be seeing, but let's just dive right in. First, let's see why we need the Winograd Schema challenge. Well, the Turing Test was an idea proposed by Alan Turing in 1950. He stated that if a human were unable to identify that they are speaking with a machine after having a free written, that is very important, a free written conversation, then that machine would have passed the Turing test and it can be said to be intelligent. This right here is the standard Turing test, where a human judge has a conversation with both a real human and a machine. And then they need to say which is which. But the Turing test has some drawbacks. Machines can trick humans by pretending they are real humans and simply don't know the answer to a question, when actually what is happening is that they didn't understand the question itself. They can also learn to pretend being humans by creating a personality which justifies their behavior. However, a real intelligent machine should not need these tricks to prove its intelligence. An example of this trickery is the bot Eugene Gustman, who was the first to pass the Turing test in 2014. He claimed to be a 13-year-old Ukrainian boy, and this allowed him to have grammatical errors, avoid questions due to supposedly lack of knowledge, and overall construct an identity which can more easily pass as a human being. Let's now dive into what is actually the Winograd Schema challenge. Trying to avoid these drawbacks of the Turing test that we have talked about, Winograd schemas were created by Levesque, Davis, and Morgenstern in 2012. They consist in a pronoun disambiguation problem, where a sentence contains references to two different entities, in this case a trophy and a suitcase, and a word referring to one of the entities, in this case big, which can also refer syntactically to the other entity. And basically the question is, what is this pronoun referring to? In this case, for any human, it is obvious that the correct answer is the trophy, right? But why do we know this? This is the logical reasoning we are performing in our minds as humans. We know that if something does not fit in a container, then either the container is too small or the item is too big. Now, in order to lower the probability that someone could exploit text analysis techniques such as word order or frequency to solve the schemas, special and alternate words are used, as can be seen in this example. This is exactly the same schema that we have seen before, including now these words, which would replace the placeholder in the sentence. As before, we can have the sentence, the trophy doesn't fit in the brown suitcase because it's too big, and then it asks what is too big, and the answer would be the trophy. So far, so good, nothing's changed. But now we must also solve the parallel sentence. The trophy doesn't fit in the brown suitcase because it's too small. What is too small? And now the answer naturally changes to the suitcase. This is the magic behind Winograd schemas and where they differ from pronoun disambiguation problems. And the Winograd Schema Challenge is basically a competition where contestants are proposed some Winograd schemas and they need to answer them correctly in order to win a big prize. The first Winograd Schema Challenge was held at the IJCAI conference in 2016. In this competition, first a pronoun disambiguation phase will determine the contestants who have a high chance of actually being able to solve the challenge. If a contestant answers correctly at least 90% of the posed problems, and that's a lot, they may move on to the second phase, where actual Winograd schemas will be presented. Otherwise, that year's edition will be closed, and the winner will be the person to perform better in that first phase. The organizers of the challenge really want to advance the common sense reasoning field. They encourage researchers to publish their methods, their algorithms, knowledge representation bases, and any other material used to solve the challenge publicly. Otherwise, even if someone managed to solve 100% of the Winograd schemas correctly, they would be disqualified unless they published a paper.
So, let's now talk about the results of the challenge until now. Given the poor information provided by the official webpage of the challenge, and since the papers from 2018's edition have not been published yet, we are going to analyze the results from 2016's challenge edition and the more recent results exposed at the 2017 Common Sense Reasoning Symposium. 4 independent researchers and students from around the world entered at this first edition of the competition, one of them with 3 systems. The table summarized the results of the 6th system at the PDP's phase. The asterisks from Quan Liu's 3 systems are due to a problem with unexpected punctuation in XML input. The correct scores are the starred one. As you can see, no system reached the 90%, so the second phase of the competition was not carried out. What's more, most of them do not even surpass the random guess accuracy. Quan Liu obtained the highest score in the first edition, 58.33% of accuracy. But what happened if we compare the result with the obtained by the group of human subjects that year? The group was formed by 19 humans, 12 of them non-native English, and they performed the PDP's phase with an overall average of 19.9% answered correctly. So we can say that the accuracy of the winner is really low. Quan Liu explained the details about his system and results in a paper which was presented at the 2017 Common Sense Reasoning Symposium. In the paper, Quan Liu proposed common sense knowledge enhanced embeddings for solving the PDPs. The role of the KEE models is to provide a general framework to make use of common sense knowledge for extracting representative futures to make decisions, and then based on KAE, propose two methods to finally answer the PDPs. So, what is KEE? Well, traditional features that are useful for standard co-reference resolutions are not useful for the PDP task, and it is necessary to use common sense knowledge by extracting the context feature for each pronoun and candidate mentioned in the PDP. To train semantic word embeddings to extract the context feature, We can incorporate several common sense knowledge bases into the word embedding learning process. For learning knowledge-enhanced embeddings and train the KEE model, the researchers made use of common sense knowledge bases that are widely used in both the AI and the NLP community to collect knowledge constraints. The framework used three common sense knowledge bases: ConceptNet, WordNet, and COSCOM. About these knowledge bases, ConceptNet is a semantic network containing lots of things that computers should know about the world, especially about understanding text written by people. It's built from nodes representing words or short phrases of natural language and labeled relationship between them. WordNet is a lexical database for the English language. It groups English words into a set of synonyms called synsets, provides short definitions and usage examples, and records a number of relations among these synonyms set of their members. So, WordNet can be seen as a combination of dictionary and thesaurus. Finally, COSCOM is a set of cause-effect pairs of common words automatically collected from large text corpus. Actually, the COSCOM knowledge base is proposed to avoid data sparseness problem, since the vocabulary of the knowledge bases covers common words but no phrases in daily life, like common verbs, adjectives, and so on. Now, with the feature extracted by the KE, we can solve PDP problems. The paper proposed two methods to resolve them. The first one, unsupervised semantic similarity method, that projects the knowledge learned by the KE into a low-dimension space vectors, and calculate cosine distance to select the answer from the candidates. On the other hand, the neural knowledge activating method uses the composed embedding vector as input feature to train a deep neural networks, with a classifier for select the answer. But this solution is an improvement of the original that he presented in the 2016 competition. The system presented at the competition used a small set of COSCOM knowledge, and the KE model was trained on a smaller Wikipedia text corpus. For the problem solver was used the neural knowledge activating method. On the other hand, with the improved method, the results obtained using the Wikipedia corpus as the training source of the KE model, the three knowledge bases, and a system that combines both problem solvers, was able to achieve an accuracy of 66.7%, which is a new state-of-the-art performance. And at the picture you can see the overall system. What has been done in the Winograd Schema challenge recently? First, we have the language models method. Language modeling is the development of probabilistic models that are able to predict the next word in the sequence given the words that precede it. The language model learns the probability of word occurrence training on a massive amount of unlabeled data. Then the system works as follows. First, we train an array of large recurrent neural networks, language models that operate at word or character level. Once trained, the next step is to substitute the pronoun in the original sentence with each of the candidate choices. The problem of coreference resolution is reduced then to identifying which substitution results in a more probable sentence. The LMs are able to assign probability to any given text based on what they have learned from training data. With this model, the author achieved a 70% of accuracy of the PDPs. Let's see an example. If we take the PDP explained before, we have two possible candidates, that the trophy is too big or the suitcase is. Well, the language model substitutes in the sentence the pronoun it for its candidate and calculate the probability. The one with the greatest probability in this case is trophy. So the answer that the system returns is that the trophy doesn't fit in the suitcase because the trophy is too big. Another interesting recent method is known as knowledge hunting framework that gathers text from the web, and that text serves as evidence for candidate problem resolutions. The system generates relevant queries from an input problem, and those queries are sent to a search engine, and with the results, the system makes a resolution. With this method, the author achieved a 67.6% of accuracy. A summary of the most recent results in solutions to the PDP phase of the Winograd challenge are shown in the table. Looking at the most recent results, we can say that with respect to the first edition of the competition, all systems outperforms the random guess in this type of problems. However, pending the result of the 2018 competition to be revealed, none is close to pass the PDP phase. These results reflect how far the machines are from understanding human language and common sense reasoning, but the researchers are on the right track.
Now that we know what the Winograd Schema challenge is, let's see what other challenges there are in the common sense reasoning field. The Loebner Prize is an annual competition in the format of a standard Turing test. In each round, a human judge simultaneously holds textual conversations with a computer program and a human being via a computer. And based upon the responses, the judge must decide which is which. Now, in the first editions, this simultaneous conversation was limited to 5 minutes. And from 2010 onwards, the time limit has been increased to 25 minutes, which is still a very small amount of time to determine whether you are speaking with a human or with a computer. The Loebner Prize competition has been highly criticized by experts in the field. Competition entrants do not really aim at improving the understanding of machines or their intelligence, but simply resort to trickery to win the competition. Successful entrants find that deception is rewarded. The Recognizing Textual Entailment, also known as RTE challenge, is a benchmark based on recognizing whether a text fragment can be inferred or entailed from another. It is said that the text T entails the hypothesis H if a human reading T would easily infer H. Let's look at this example. The text is Norway's most famous painting, The Scream by Edvard Munch, was recovered 3 months after it was stolen. A human reading the text, this first sentence, will instantly know that the hypothesis that Edvard Munch painted the Scream is true. There are, however, some problems with RTEs. First, that there is no formal definition of entailment. This whole challenge and these type of text hypothesis pairs are simply based on this fuzzy definition of entailment. One person may judge that one sentence entails another, while a different person may not even think about that inference. And it is also very hard to balance the difficulty of the challenge. Previous year's editions tended to focus more on inferences due to the text fragment rather than common everyday inferences, which was the actual goal of these pairs. Next, we'd like to provide a little discussion on what we think about the Winograd Schema challenge. About this first edition from 2016, there exists only one web page providing information which is not updated, and it only cites the winner paper for the edition without even mentioning the rest of the contestants. Now, to our eyes, it would have brought good publicity to the challenge if all the papers had been published on the main webpage of the commonsense reasoning organization. Instead, we have had to use specific academic literature search engines to look for articles which aim to solve the Winograd Schema challenge. This poor information is the topic of the challenge, basically. In the edition of 2018, we only know that it has supposedly taken place, but there is no information on it. Not on the official webpage of the challenge, not on the webpage of the conference that it took place at. To us, it seems strange that no results are yet available, since other competitions, such as the previously mentioned Loebner Prize, have already uploaded their results and they are available on their web. It seems like a lost opportunity to attract more contestants, which is perhaps the organizers' intentions after all. Being the second edition, they might want to set a good basis for future challenges and that take a longer time to put everything in order. Perhaps the main problem we identify is the difficulty to create an effective and sufficiently large corpus of schemas. As we know, they should be original. They should not be found on Google or any other search engine, and they need to contain the special and alternate word. All of these means that they should be manually generated by humans without the help of any external references. Then the corpus creation process is obviously long and hard to balance the difficulty and the obviousness of the schemas, so they will rarely be uniform. This, for a contest which aims at being held yearly or biannually, represents a huge effort which the organization may not be willing to take unless the number of contestants is high. Finally, we'd like to leave you with some final thoughts on what we take from this project. With the information we have gathered, we conclude that the Winograd Schema Challenge has the potential of becoming an important competition in the artificial intelligence research community, even though the creation of the corpus of schemas is really cumbersome. We believe the organizers of the competition should focus on promoting it through a redesign of their official webpage and the publication of related papers presented at different conferences, basically giving more publicity to the challenge. In the next years, we predict that common sense reasoning and knowledge representation will see an increase in interest, due mainly to the broad use of personal AI assistants, and the Winograd Schema Challenge will promote the creation of more intelligent machines. In the near future, perhaps in a couple of years, the pronoun disambiguation phase will probably be overcome, and actual solutions for Winograd schemas will start to appear. In that moment, computers will understand humans exceptionally better. We'd like to thank you for your attention and feel free to leave any questions in the comments.